Thousands of minor particles are in the large planet's orbit under its control. The International Astronomical Union has determined that the smallest moons will no longer be given mythical names unless they are of significant scientific interest, since astronomers are become so skilled at finding tiny moons orbiting far off massive planets. The 4 biggest moons of Jupiter were the first extraterrestrial bodies to be identified, after the Italian astronomer Galileo Galilei, who first noticed them in 1610. They are known as the Galilean satellites. Galileo is credited with discovering the moons, even though German astronomer Simon Marius claimed to have observed them about the same time. However, Marius did not record his observations, therefore Galileo is given the credit. Europa, a moon of Jupiter, may have a carbonated ocean. However, not in the sense that it is fizzy, but rather that it is rich in carbon dioxide. This theory, which is based on observations from the James Webb Space Telescope JWST, may be essential because carbon is a crucial element for life, which is why it is a point in favor of the existence of habitable conditions beneath Europa's icy exterior. The JWST observations were examined separately by 2 groups, who both came to the same conclusion. The frozen surface of Europa appears to be being penetrated by carbon dioxide. It is especially common in a region known as Terra Regio, where the terrain is chaotic and jumbled with pits, ridges, fissures, and domes. The Terra Regio is thought to be a relatively young region of the surface, formed by interactions with the subsurface ocean millions of years ago. Geronimo Villanueva of NASA's Goddard Space Flight Center in Maryland claims that the chaotic terrain, which is geologically younger than other sections of Europa, is producing the strongest signal. That indicates that it is very likely that this material is brand new and that it must originate from the interior. The concentrations were higher overall in the chaos terrain and did not match what we would anticipate if comets had carried the carbon dioxide to Europa, since all known living things rely on carbon as a building block for more complex compounds known as organics. This is good news for the possibility of life existing under Europa's cold crust. According to Samantha Trumbo of Cornell University in New York, carbon is a biologically essential element, so it's important to figure out how it got to Europa, how much of it there is, and in what form it's there. JWST has only seen Europa once so far. We should eventually have a more full perspective of its surface thanks to the 3 more views that are planned, which will provide us with a wealth of information about the composition and possible habitability of its seas.